Hello everyone, thanks for joining us today. My name is Sepideh. I am the Principal AI Lead at Woodside with over 20 years of experience in software engineering and a dedicated focus on AI over the past 7 years. Today, I'm not here to talk about Woodside or any work that we do there. Instead, I'd like to share my experiences and insights on building and architecting AI solutions. Since I only have 20 minutes, I'll focus on providing strategic tips during my presentation, starting with some basic concepts to establish a common ground. Let's get started. This is my disclaimer. Let's start with the fundamental question. What is AI? Artificial intelligence is the intelligence demonstrated by machines in contrast to natural intelligence displayed by humans. It is when machines are able to perform tasks that usually require human intelligence. What is Gen AI? Generative AI is a type of AI that creates new content like images, text, music, by learning patterns from existing data. For example, all the images in this presentation are generated by AI. Raise your hand if you have built an AI solution. Raise your hand. Very good. Cool. Okay. What is AI solution? An AI solution refers to a system, application, or tool that utilizes artificial intelligence technologies to solve real-world problems, automate tasks, enhance processes, or improve decision-making. What is reliability? Reliability means the system consistently performs its intended function accurately over time. Raise your hand if you know why AI reliability matters. Raise your hand. Okay, that's good. As artificial intelligence plays a larger role in our daily lives, it is more important than ever that AI systems are built to provide a helpful, safe, and trustworthy experience for everyone. An unreliable AI system can lead to costly errors, jeopardize safety, and damage public trust in the technology. AI reliability is crucial because it ensures trust, safety, and consistent performance when these systems are used in the real world. Well, what are the characteristics of a reliable AI solution? I picked 4 for you. For AI to be reliable, it needs to be accurate and consistent in producing results that we can depend on. It also has to be robust, which means it can handle diverse and unexpected inputs without failing. AI systems should not cause harm, and they should be tested extensively to ensure safety, particularly in high-stake environments. Trustworthiness is a fundamental characteristic of a reliable AI solution. It represents the confidence users and stakeholders place in the AI system to operate in a way that can be dependent on. Emphasizing reliable generative AI solution over normal solution is critical because of the unique challenges and opportunities presented by generative AI. Here is why this emphasis is so important. Generative AI models, such as those used in content generation, can produce highly variable outputs. Unlike traditional systems, where outputs are predictable and based on clear, rule-based algorithms, generative AI can produce a wide range of results depending on the input data and model structure. This variability makes it essential to keep the system reliable to ensure quality and prevent any negative effects. Generative AI models are highly complex, often involving millions or billions of parameters that are trained on vast datasets. This complexity makes it difficult to fully understand or predict how the model will behave in different situations. Gen AI can produce unintended outcomes by not following instructions. A big challenge in Gen AI is hallucination, where the model generates outputs that are factually incorrect or just don't make sense. Gen AI systems are vulnerable to adversarial attacks, where malicious input can lead to unintended or harmful outputs. Well, how to build reliable AI solution? Typically, all AI projects go through 6 major stages in their life cycle: selection, design, development, evaluation, deployment, and monitoring. And it is an iterative process. I'll share a few tips for navigating this cycle. Selection. Using generative AI for the wrong business use case leads to high failure rates and diminishes the value of AI in organizations. The hype surrounding Gen AI can lead IT leaders to apply it where it is not a good fit, increasing the risk of higher complexity and failure in their AI projects. AI techniques are not mutually exclusive. They can often be combined to create a stronger overall system. Define goal and constraint. Know your problem, user, environment, data, and your assumption. To build reliable AI, we must start by defining clear goals and constraints that guide its development. Have an AI system view. Building a successful AI solution entails more than just consuming an AI model. The engineering complexity and effort associated with building and deploying robust, reliable AI solution is often underestimated. High-quality data and diverse data is essential for any AI model to work effectively. LLMs are limited to their original training data, making them static, potentially outdated. Additionally, AI applications require custom data for domain-specific responses, like customer support or internal HR queries. The main challenge is achieving this customization without retraining the model entirely. In context of Gen AI, RAG, or Retrieval Augmented Generation, combines retrieval-based methods with generative model. RAG is now an industry standard. This approach enhances content quality, relevance, and accuracy by incorporating organizational knowledge during generation, making it valuable for cases that require custom domain responses. Evaluate. Evaluating the performance of machine learning models is crucial for determining their effectiveness and reliability. To do that, quantitative measurement with reference to ground truth output, also known as evaluation metrics, are needed. However, LLM applications are fast-evolving ML field, where model evaluation is not straightforward. Several metrics have been proposed in the literature for evaluating the performance of LLMs. It is essential to use the right metrics that are suitable for the problem we are trying to solve. Monitor. It's crucial to continuously evaluate and monitor your AI system to ensure they maintain their performance and reliability. Explainability is key. it helps us understand how the AI model makes decisions and build trust in its output. Being transparent about how AI model works and their limitation is equally important. I recommend adopting a holistic, multi-layered approach when designing and evaluating AI solutions. This strategy involves establishing well-defined layers that guide both development and assessment. To effectively manage content risks and minimizing low-quality output from LLMs, implement an iterative, structured approach that emphasizing ongoing experimentation and continuous measurement. Let's go through these layers. The first layer is model layer, and it's all about model understanding. First, it is important to thoroughly understand the capabilities and limitation of each model before starting to build your AI application. Then, it is essential to examine any safety fine-tuning applied. For example, Microsoft has collaborated with OpenAI to incorporate techniques like reinforcement learning from human feedback and fine-tuning in base models to enhance built-in safety measures, helping mitigate unwanted behaviors. By understanding and using these models, developers can take advantage of the safety features embedded within them. Next layer is safety system layer. Selecting a strong base model is just the beginning. For most AI applications, relying solely on built-in safety feature is not even enough. Even fine-tuning LLMs can make errors or be vulnerable to attacks like jailbreaks. In many cases, an additional safety system is required to provide a separate layer of protection, blocking risky content from being produced. Content safety is about content moderation, and it is a content moderation approach that goes around the model and monitors the input and outputs to help identify and prevent attacks from being successful and catches places where the model makes a mistake. For example, Azure AI Content Safety. This safety system works by running both the prompt and completion of your model through an ensemble of classification models aimed at detecting and preventing the output of harmful content across a range of categories, such as risky content containing hate, sexual, violence, and self-harm language, jailbreaks, or indirect attacks. Next layer is system message and data grounding. The design of system message and the proper grounding of data are fundamental to any generative AI applications. These elements are not only create a distinct user experience, but also play a critical role in reducing errors and mitigating risks. We talked about RAG as an effective and flexible architecture. With RAG, you enable your application to retrieve relevant knowledge from selected dataset and incorporate it into your system message to the model. In this pattern, the model functions as a reasoning engine over the data provided to it during query. This improves the freshness, accuracy, and relevancy of input and outputs. In other words, RAG can ground your model in relevant data for more relevant results. Now, the other part of this story is how you teach the base model to use the data or to answer the questions effectively in your application. The system message is used to communicate instruction and or provide context to the model at the beginning of conversation. The system message typically guides the model's behavior, sets the tones, or specifies desired output from the model. You can use the system message to describe the assistant's personality, define what the model should and shouldn't answer. This is an example of a system message. By utilizing the system message effectively, you can steer the model toward generating more accurate and relevant responses. This is another example of a system message or set of instructions that is used for managing content risks. Next layer is user experience layer. Implement user-centered design, UX best practices, an intervention to guide users toward using the system as intended. These practices also help prevent over-reliance on AI systems. For example, highlight potential inaccuracy in AI-generated outputs both when users first start using the system and at the appropriate times during ongoing use. User responsibility. Remind people that they are accountable for the final content when they are reviewing AI-generated content. For example, when offering code suggestions, remind the developer to review and test suggestions before accepting. Disclose AI roles in the interaction. Make people aware that they are interacting with an AI system. Cite references and information sources. If your system generates content based on references sent to the model, clearly citing information sources help people understand where AI-generated content is coming from. To wrap up, building reliable generative AI is not just about technology. It is about trust, safety, and making sure these systems work well in our real-world environments. Thank you, and thanks our sponsors. Thank you.
Thank you, Sep.
I will be around. If you have any question, I will be around and we can have a chat.
We
Thank
still
you.
have 3 minutes for questions if you'd like to answer them.
Yep, we can ask questions.
Anyone has any questions?
Hey, thanks. Great talk. I was just wondering, are you using it in Woodside, or has it been leveraged much, generative AI?
Yes, we are using, although I mentioned that this talk is not about Woodside, but yes, we are using generative AI at Woodside and building lots of applications.
You building anything yourself?
Yes.
Oh, cool. Wonderful.
So in your slides, you had a section called a secure system that you wrap the model around. And then outside of that, you had meta prompting and grounding. So how is the secure system different to the meta prompt or grounding?
This is an approach that Microsoft promoted as well. So these are the different layers of the protection. So there are platform and there are application. So at the platform, you are working on the area that is kind of almost common across all the application. So you built in those safety at that level. And more models, and you wrap around those. But on the application level, it really depends on your application and the requirement that your application has. So those system message and grounding data, it really depends on your application. That's why there are different layers is designed in there. That's how it's different.
Thank you for your presentation. Yes. I just had a question on whether you think it's appropriate or useful to have an independent LLM performing the evaluation and the monitoring of another AI system?
So Like if you use, for example, Azure, obviously they are subject matter experts and they are built in those fine-tuning. So it makes our job easier. But that doesn't mean that we solely rely on those models. So, but if you are using independent one, then you need to understand the models, test it thoroughly to get all the capability. That's the first layer to understand it. And depending on your application, you need to build on those fine-tuning and those controls around your model. Both ways are valid, but you need to build in those protections and controls in place depending on your use case.
Alrighty. Thank you so much, Sep. A huge applause for Sep.
Thank you.